Hello, Math 7 students. This is Open Up Resources Unit 2, Lesson 2, Introducing Proportional Relationships with Tables. To get us started, I just want us to take a second and do a notice and wonder. We have a table here that shows how many paper towels a store receives when they order a different number of cases. So what I want you to do is just take 60 seconds. What do you notice about the table? 60 seconds. I'm going to continue on with the video, but I want you to pause it for 60 seconds and look at that table. What do you notice? Now that you've done that for 60 seconds, the next question is, what do you wonder? What questions come up as you're looking at this table? Again, pause the video, give yourself 60 seconds of think time. What do you wonder? All right, and the students who are in class, this is something that they noticed. They noticed that whatever I do to the left-hand side of the table, I'm doing the same thing to the right-hand side of the table. 1 multiplied by 3 is 3, and 12 multiplied by 3 is 36. So whenever I multiply this side by 3, I'm doing the same thing to the right-hand side. We can see the same thing here with the 2. 5 times 2 is 10. 60 times 2 is 120. So even though I might be multiplying by a different number, I'm still doing the same thing to both sides. So I'm going to write that down as well. 5 times 2 is 10. 60 times 2 is 120. And again, when I multiply the left-hand side by 2, I'm doing the same thing to the right-hand side. And I'm abbreviating here, LHS left-hand side, RHS right-hand side. Another important thing that was observed in class is this right here. There are 12 paper towels in a case, 12 rolls of paper towels in a case, because here's the 12, here's the 1. That means when I order one case, I'm getting 12 rolls. 12 rolls in a case. And the next thing that was really important to observe is this. The 1 changes to a 12 by multiplying by 12. The 3 changes to a 36 by multiplying by 12. And we see this because there are 12 rolls of paper towels in each case. So if I have 5 cases, that's going to be 12 rolls in each case, and that's how I get that 60. So I'm going to add that. We multiply by 12 as we go across the table. And now it's time for the what do you wonder? What kind of questions came up as you looked at this table? What did you wonder, Chandon? Good, so you're recognizing that there's that pattern here where we multiply by 3, but it's not so easy to turn like a 3 into a 5, right? Good, that is something really interesting to wonder is why did we even put these specific numbers on the table? Like why 1, 3, and 5 in the table? Why not 2 and 4, right? Okay, what else did you guys wonder? Jada? Yeah, why did we multiply by 2? And now, these are all great questions to wonder, but I want to focus on the less mathy things. What are some things that you wonder just based on the situation, not focusing on the math or the numbers? What about you, Emma? Why would someone order 10 cases of paper towels? I know the answer to that. COVID. Right, though? It's no longer a question anymore why someone would order 10 cases. After this year, we kind of get it now. Why would someone order 10 cases? What did you wonder, Sam? Why 12 in a case? Okay, and I have a question. I want to know how many paper towels are on a roll. It's a good one, right? How many towels on a roll? And we can't answer that based off of what's there, but it does make me wonder. Okay, and let's move on. What I want us to do as we move forward, I want us to start looking at these tables and looking for some of these same relationships. You guys already observed this beautiful relationship that was already marked. 5 times 2 is 10, 60 times 2 is 120. But you saw the same thing here. 1 times 3 is 3, 12 times 3 is 36. And you also found a relationship as you went across the table. And that's also really important too. So take all of those patterns as we move on to our next activity, feeding a crowd. A recipe says that 2 cups of dry rice will serve 6 people. Complete the table as we answer these questions. So we can see that this information is organized in a table now. We have cups of rice and number of people. So 2 cups of rice and 6 people. 3 cups of rice would then serve 9 people. But what about 10 cups of rice? Let's look for a relationship so that we can answer how many people that will serve. And also, what if there's 45 people? How many cups of rice will I need? Pause the video and give yourself a chance to think through this as these in-person students talk with their groups. Ready, set, go. All right, now that we're back, we've had a chance to think and we've had a chance to discuss with our groups. I don't want the answers. I want to know how you're getting the answers. So, how did you answer the question about how many people 10 cups of rice will serve? What did you do, Jackson? But why did you multiply 10 by 3? You got it. Exactly. That's one of those beautiful patterns in that relationship. 2 times 3 is 6. 3 times 3 is 9. So we've looked at the relationship that already exists, and then we're going to use it. So since I multiplied by 3 to go across here and here, I'm probably going to multiply by 3 to go across again. And 10 times 3 is 30. Great. But now, how does that help me for this one? I want us to think about, like, this relationship is great. It helps us go forward. But what if I don't even know what the number is? How do I go forward if I don't even know what that number is? What are your thoughts, CJ? We could go backwards. Since going forwards, I'm multiplying by 3, then when I go backwards, I would probably divide by 3. What's another way that I could get that same result? We've been through this, make some connections. I can't tell whose hand that is. Is that Fitz? Fitz. Okay, we'll get to that pattern in just a second. That's a good one, and we're going to get there in just a second, but I want to focus on this. I can work backwards this way, 45 divided by 3, but what else could I do, Sam? Exactly, multiply by 1/3, make this connection. Dividing by 3 is the same as multiplying by 1/3. That's going to be really helpful. Either way you do it, 45 divided by 3 or 45 multiplied by 1/3, we get what? Jada? We do get 15. Great. Now, we answered these questions. Let's actually write out the answers instead of just keeping it all on the table. How many people will 10 cups of rice serve? That will serve 30 people. But I don't want us to just write 30 people. I want us to remind ourselves how we got that answer. We started with 10. We multiplied by 3 to go across the table. And that's how I got the 30. Please make sure you are including that in your notes. And we've also answered this question. If we're going to serve 45 people, we're going to need 15 cups of rice. So that means I actually did the 45 divided by 3, and that's how I got the 15. Make sure you're writing down your calculations. Anytime you plug something into your calculator, it should still be on your paper so that you know how you got there. Let's look at those other patterns that were mentioned. Fitz mentioned this. He said, hey, I know how a 9 can change into a 45. Not enough hands. Thank you. 9 changes to a 5. Luke. It's okay. If you forgot what you were going to say, Fitz already answered the question. Fitz, how does that 9 change to a 45? Exactly. And so can we use that relationship here? Yeah. And does it work? Perfectly. So let's tie that into something that we already know. What I want you to observe is this, and yes, this should also be included in your notes. We're going to make the connection to equivalent ratios, which is where our focus has been the last little bit. We've been reviewing that 6th grade material of equivalent ratios. And so I have 9 people and 3 cups of rice. So do you see what I'm setting up? Setting up a ratio. And we're saying, okay, well, what if there's 45 people? And we say, oh, that's easy. I know that a 9 changes to a 45 by multiplying by 5. So I'm going to do the same thing to the second part of that ratio. And the 3 is also going to be multiplied by 5 and give me the 15 are 4 cups of rice. So this is the exact same thing that we've already been doing. We're just organizing our information in a table instead. And who found any other patterns, any other relationships in there that you can see? Okay. Very few hands, and the hands go up and then they come down because they're unsure. Sam? Yes, 2 multiplied by 5 is 10. So what do I see here? 6 multiplied by 5 is 30. And again, let's tie that into our equivalent ratios. So we're also going to include that and write that one up here as well. That we have 6 people and 2 cups of rice. But I wanted to change that 2 into a 10. We said, I know how to do that. 2 is multiplied by 5. So that means this is also going to be multiplied by 5. And we get the 30 just like we thought we would. Just like it shows in our table. So now as we work on this next problem, we've got some good relationships to look for. We can go through the table, and as long as I'm doing the same thing to the left-hand side and the right-hand side, then it's going to be fine, just like here. Do it to the top, do it to the bottom. But I also want us to look for those relationships that help us go across the table. So now we have a recipe that says 6 spring rolls will serve 3 people. Complete the table again, looking for those relationships. Pause the video to get this done. In class, students, you'll be working with your groups. Ready, set, go. All right, we're back. Let's look for some relationships. What are some relationships that you observed? Good, thank you for these hands. Please get me started. Hayden. I like that a lot. That's a great strategy. That's one that we haven't used yet, but I like that. What she said is she wants to simplify this. And so you took the 6 and you divided it by 6, you said? And 6 divided by 6 is going to equal 1. So 3 divided by 6, it equals 1/2. So if I make just 1 spring roll, that's going to serve half of a person. Yeah, I love that idea. That's going to be really, really helpful. Well, that just means that you're still going to be hungry. That 1 spring roll isn't going to feed enough people, so you would need more than that. But it's at least a good start to help us kind of look and identify that relationship. What else? What did you guys do? What else did you talk about with your groups? There's not enough hands, and when we had that much group time, I should see a few more hands. Thank you. Trinity. We have to be careful. 6 can't actually go into 3. So you're finding a relationship, you're not describing it accurately, but you do notice a connection. So let's ask that in a different way. How does a 6 change to a 3? Who have I not heard from yet? Berkeley. I know what you're trying to say, and it's a good way to start to think about it. Let's go to Danny. We can divide it by 2. However, do I love it when we talk about the division relationships? No. So although recognizing that it's dividing by 3 is a good place to start, not 3, I'm sorry, dividing by 2, let's change that and think about it like a multiplication relationship. Bryn? Multiply it by 1/2. And again, when you recognize that division relationship, that's a good place to start. We just need to go the rest of the way and figure out what that means for multiplication. And this happens so much, guys. I really want to make sure that we take advantage of this and we put it in our brains as much as possible. We're going to write this down. Pencils are moving as we write down dividing by 2 is the same as multiplying by 1/2. And I like those multiplication relationships. Is it okay to just type divide by 2 into your calculator? Sure. But ultimately, as we progress through this unit, I always want to focus on that multiplication, so I want to make those connections. That even if you're going to type in divided by 2 in your calculator, you know that that's the same as multiplying by 1/2. Make those connections now so that it's easier in the rest of that unit. And I like this. 6 times 1/2 is 3. Even using what Hayden found, does that work up here too? How does a 1 change to a 1/2? We multiply by 1/2. So can we continue to use that relationship here? We can multiply by 1/2, or if you're lazy and want to type something else into your calculator, you could type in divide by 2. And 30 multiplied by 1/2, or 30 divided by 2 is equal to, CJ, 15. And 40 divided by 2 or multiplied by 1/2 is equal to, Bryn, 20. And now what do I do here? We'd be multiplying by 1/2, but I don't even know what I'm starting with. So what should I do? Naim? Multiply what by 2? And why would I want to multiply this by 2? You're right, but why? Because everything else that I'm doing is multiplying by 1/2. So why am I switching it to multiplying by 2 now? Chandon? Well, yes, but why? Look at what I'm pointing out here on the screen. Eyes on the screen. I've lost the focus of a lot of students. Eyes on the screen. Still waiting for eyes on the screen. Online learners, that means you too. You need to be paying attention. Listen to the question. Everywhere on the table, I was multiplying by 1/2. And now, the strategy that was given to me, it is correct, but they're saying it's okay, let's just multiply by 2. Why is it okay to change my strategy and multiply by 2 when everywhere else on the table I multiplied by 1/2? Why is it okay to change that strategy now? Emma? It's on a different side, so I can't do the same. So if I'm going forwards, I'm going to be multiplying by 1/2, but am I going forwards anymore? No, I'm going backwards. So that means since I'm going backwards and I've got different information, I've got to use it differently. So the 28 going backwards is going to be multiplied by 2, and I get 56. So 56 spring rolls will be enough to feed 28 people. Let's also look for some other patterns in the table. Did you guys notice this? The 6 changes to a 30 by multiplying by 5. And so we also see that a 3 multiplied by 5 is 15. Is it as easy to find that anywhere else? Can we easily change a 6 to a 40? How about a 6 to a 56? Not so easy, is it? So eyes on the screen. Since we can't always find easy relationships to help us go up and down the table, look for the relationship that helps us go across the table. With that in mind, we have this new situation, making bread dough. A bakery uses 8 tablespoons of honey for every 10 cups of flour to make bread dough. Some days they make bigger batches, and some days they make smaller batches, but they always use the same ratio of honey to flour. They use that same ratio of honey to flour because that's how they make sure that the recipe still tastes the same. So, complete the table as you answer the questions. Take a look at this. Can you easily turn an 8 to a 20? Not so easy. Can you turn an 8 to a 13? Again, not so easy, is it? So we're really stuck on trying to go down the table. So let's try and look for a relationship that goes across the table. And again, it still isn't easy, but once I find that relationship that goes across the table, then I can reuse that again and again and again to go across the table all the time. I want you to pause the video, give yourself time to think, while the in-person students work with your groups. How can we go forward? How does an 8 change to a 10? Ready, set, go. Okay. How does an 8 change to a 10? What do I need to do? Let's go with Gavin D. It is a lot easier, and I like that idea a lot. So we're going to simplify the ratio. I love that you're making that connection, though, too. That 10 cups of flour and 8 tablespoons of honey. We can simplify this ratio into 5 cups of flour and 2 tablespoons of honey. How does that 10 change to a 5 and the 8 change to a 2? Not 2, though. Not 2, 4. How does it change? Jada? We divide it by 2. I love that idea a lot. We can simplify our ratio, and that does help us. So let's divide by 2. We're going to do the same thing up here. Divide by 2. And now we ask, how does a 4 change to an 8? Still, no. 4 change to a 5. Still not super easy, but simplifying it does help. Anyone know, how does that 4 change to a 5? Let's go with Sam. Oh, you're close. Test it out in your calculator. What's 4 times 1.4? Does it actually give you 5? 1.25 is the correct. Nice recovery. Okay, and let's look at how we can answer that question. I need all eyes on the screen. If you don't know how to change a 4 into a 5 or an 8 to a 10 or any number into the other by going forwards, you can always work backwards. If it's too hard to go forwards, then work backwards. And let me show you the strategy that I'm talking about. Again, I need your eyes on the screen because this is a really important strategy that's going to be coming up again and again and again. I don't know what I'm going to do when I go forwards. It's 8 multiplied by something. You guys remember these old-fashioned equations from like kindergarten, right? Only it was something like, how does an 8 multiply, I guess this wouldn't be kindergarten, this would be like 3rd grade, but 8 times something is equal to 24. And you're like, oh, I know, that's the number 3, right? But this is not so simple. So here's the strategy that we need to use. We can see that we're multiplying this empty box that we need to fill in by 8. How do I undo multiplying by 8? We divide by 8. And whatever I do to one side, I have to do to the other side. Now, you guys probably already recognize this. When we say work backwards, you're like, oh, 10 divided by 8. You know what that means, but here's the reason why. Secretly, without us realizing it, we're actually solving an equation in our heads. Okay? And when I do this, I now know that the number that belongs in the box is 10 divided by 8, which is equal to 1.25. We can also write this as a fraction, and yes, I do want you to write it as a fraction. 10 divided by 8, when you plug it into your calculators, it doesn't give you a decimal right away, it gives you the fraction 5/4. So I want us to recognize both, so I'm going to write that down as well. Multiply by 1.25 or multiply by 5/4. And now, each time we go forward in the table, we're multiplying by 1.25. Test it out. 8 times 1.25, does it give you 10? Okay, 20 multiplied by 1.25. What does it give you, Danny? It is 25. And 13 multiplied by 1.25. What does it give you, Berkeley? 16.25. So what should I be doing if I'm wanting to go backwards in this table now? Am I still going to multiply by 1.25? No, what am I going to do? Naim. Divide by 1.25. And 20 divided by 1.25 is, CJ? 16. Okay, we filled out the table. Now let's answer these questions. How many cups of flour do they use with 20 tablespoons of honey? Here's our 20 tablespoons. And the answer is 25 cups of flour. We're writing this down. We showed our work on how we got all of these answers in our table, but we're going to write it down. And again, how did I get that 25? I started with 20. I multiplied it by 1.25, and that's how I got the 25. How many cups of flour do they use with 13 tablespoons of honey? That was 16.25, or 16 and a quarter cups of flour. Again, how did I get there? We did 13. We went forward across that table, so I multiplied by 1.25, and that's how I got the 16.25. And to work backwards, how many tablespoons of honey did they use with 20 cups of flour? That was 16 tablespoons of honey. How did we get there? We worked backwards, and we started with the 20, and this time we divided by 1.25, and that's how I got the 16. What is the proportional relationship represented by this table? We are going to answer that next time. That's it for today's video. Thank you for watching. We'll see you next time.